Hello, our project is called CoastalWatch, an advanced coastal monitoring system protecting communities through real-time environmental surveillance and early warning systems. Coastal areas are very important. They provide homes for millions of people, support fishermen, protect biodiversity, and store what we call blue carbon, which helps fight climate change. But at the same time, they are also very fragile. Every year, coastal regions are hit by problems like storms, floods, pollution, illegal dumping, and rising sea levels. These threats not only damage the environment, but also affect people's lives, livelihood, and the economy. The biggest challenge is that many communities and authorities don't get timely warnings. By the time the action is taken, it's often too late. That's why we decided to build a solution that can detect these threats early and alert the right people instantly. Our system aims to save lives, protect ecosystems, and build safer coastal communities. Our mission is to provide comprehensive coastal monitoring system that protect lives, property, and ecosystem through cutting-edge technology and real-time data analysis. Our vision is to create a world where coastal communities are equipped with the knowledge and tools necessary to respond effectively to environmental threats and climate change. This is the About page of our system. Now, let's move on to the home page of the system. This is the home page of Coastal Watch. Here we introduce our platform in a very simple way. You can see the project title along with a short description. It is an AI powered guardian for the Indian coastline. On this page, we also provide two direct buttons. A button that takes you to the live dashboard and another that lets you know more about the system. Below that, we display the current coastal status. It shows the active alerts. This shows how many critical warnings are live right now. Then, Sensors Online tells us about how many sensors across the coastline are working. Average water level helps the authorities know whether sea levels are stable or dangerous. And wind speed calculates the average wind speed across the last 10 readings. Now, let's move on to the dashboard. The dashboard gives a real-time monitoring view. At the top, we see the current values for alerts, sensors, water level, and the wind speed. The central part shows a sensor map. This helps us quickly locate where threats are happening. On the right side, we have the recent alerts section, which highlights the last 10 days of threats. This allows disaster management teams to track patterns. For example, whether a particular area is repeatedly facing risks. We also have a auto run button, enabling which calls an API which responds with the recent readings. The reading is then analyzed with our AI model, which categorizes the threat level by historical data analysis and returns a notification if the threat is detected, as you can see here. This is also displayed in the recent alerts and auto updated. Now, at the bottom of the page, we see the sensor details. Here we can see all the active sensors, their location, their latitudes, longitudes, and where they are located. Now, we move on to the sensor details page. This page goes a little deeper. It shows the location of a specific sensor on the map, along with the graphs of water and wind trends. For example, you can see the current water level, the average, the minimum, maximum, and whether the trend is going up or down. Similarly, wind speed is also shown in the same way. This trend analysis is very important because it doesn't just show the current data, but also gives insight into how the situation is changing over time. That's where our AI system can step in to predict if a dangerous condition is likely to occur soon. Now, we move to the alert history page. This section keeps the record of all alerts that the system has generated. You can filter the alerts and search them based on their severity. Every alert entry shows the type of message, severity level, exact location where it happened, and the timestamp. This history is very useful for long term monitoring, for making policies, and for researchers studying coastal changes. It makes the system transparent and reliable. So, overall, the Coastal Threat Alert System is designed to provide early warnings, save lives and property, protect blue carbon habitats, and support sustainable coastal management. We believe that this system can be a strong step forward in helping coastal communities become safer and more resilient against future threats. The tech stack we have used. For backend, we have used fast API and AI analysis. For frontend, vanilla JavaScript plus React, Leaflet for map, and Recharts for graph. For now, we have integrated the system with mock datasets, but with scale, we can call APIs for accurate data from satellites, etc. This was our Coastal Watch system. Thank you.